following variables, we need to use the Excel workbook called the optimal portfolio with 2 risky assets and a risk-free asset. First of all, we need to type in all the information that's given. So we need to change the expected return and standard deviation of the risky assets. So for the debt, it will be the stock at here. So the expected return will be 25% and standard deviation will be 49%. For the expected return of the equity, it will be the expected return of bond, which is 9%, and the standard deviation will be 8%. The correlation between the fund's returns will be 1%, so we type in here. And for the risk-free asset, the rate of return is 6%, so we put it here. Then we need to change the formula. So the risky portfolio weight in debt will be 1 minus the risky portfolio weight in equity. And then we need to make sure the net exposure of the risky portfolio equals to sum of weight of stock and the weight of bond. Then we can use solver to solve this question. So we go to data, solver, and we need to change, we want to minimize standard deviation. So we choose standard deviation and minimize. Then we want to change the weight of bond and weight of stock to find our solution. And also we need to add a restriction where we want to set net exposure of the risk portfolio equals to 1. Oh, I already have it here, so it doesn't allow me to do it twice. Then we click solve. Yes, so we got our answer. Therefore, the weight of stock will be 97.55%. Sorry, that's the bond. So weight of stock will be 2.45%, and weight of bond will be 97.55%. And meanwhile, we already have our expected return of risky fund and standard deviation of risky fund, which the expected return will be 9.39%, and the standard deviation will be 7.91%. Then we are going to solve for the minimum variance portfolio of our investments in expected return and standard deviation. So now we are going to work on the complete portfolio expected return and complete portfolio standard deviation. So we basically just do the same thing. We change it to 1 minus the complete portfolio weight in the risky portfolio to find the weight in risk-free asset. Then the net exposure of the optimal portfolio will equal to the sum of weight of risky asset and the sum of weight of risk-free asset. So that must equal to 1. And we use solver. So still we want to maximize the Sharpe ratio. So we find Sharpe ratio and then maximize. And what I want to change is the complete portfolio portfolio weight in the risky portfolio. Then we delete this. We want to add a new restriction, which the net exposure of the optimal portfolio must equal to 1. Okay, then we solve for it. We got the answer. So the expected return of the investment will be 6.53%, and the standard deviation of investment will be 1.24%.